Effective nuclear charge is how we explain some of the trends on the periodic chart. It especially helps understand why the elements contract or get a little smaller as you go to the right in a row. And you'll hear more about that in the next section. So I have a picture of 3 atoms here. They are all in a row, so they would match up with each other, all being in the row. So it's lithium 3, lithium 4, beryllium 4, and boron has 5 protons. So with an atom, there's kind of 2 types of push-pull forces going on. So the nucleus is always trying to pull the electrons in towards itself. But at the same time, the electrons are trying to push each other, but especially the ones further from the nucleus, away. So what really happens, and I like to think of this as people at a big family gathering, something like that. Let's say that you've got 3 adults outside, 1, 2, 3 adults outside. And let's say you have 2 toddlers outside. Well, 2 of those adults are about to get super occupied, keep an eye on the toddlers, make sure they don't make a mess of things and that they don't get hurt. So it effectively cancels out, and I'm not saying that they go away, but these 2 guys do something called shielding, and it just makes it so that it's harder for the outer electron to interact with all of the protons in the nucleus. It means that really there's just one parent left to keep an eye on and constantly call that one electron in. And like I said, these ones are occupying the attention, and so there's not a lot of protons to pull on that electron. Now we're going to scooch over. We're keeping everything neutral. So every time I add a proton, see there's 1, 2, 3 like before, but then there's a 4th. I also add an electron because there's 4 protons. You need 1, 2, 3, 4 electrons. So we still have this push-pull thing going on, except that we have 4 parents outside. And here's where it might surprise you. So again, the 2 electrons kind of sort of tie up 2 of the parents. And they do this little shielding thing. So the parents and the electrons, that are on the outside aren't seeing each other. But we still have 2 parents that aren't marked out that can still see. Here's the deal. This parent, at any point of time, can be calling in that electron and this electron. It's not like one proton is designated to one electron. It's not like that. So at any point in time, both of those electrons can be pulled in by that proton as well as by this proton. So, and it may be hard to see the way I drew it, and I'll draw a different, I'll make sure that I do a different proton next time. But they have kind of a double pull as opposed to this one. He only had a single pull. This one are being pulled in twice. And what it means is that they are held in just a little tighter because there's an extra pair of parent eyes keeping them from running out in the woods or the lake or wherever they are. Now we're going to jump over one more atom. And this one has the 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5 electrons. And then I'm going to cross out 2 in the center that are going to keep an eye on these inner electrons, and then they cause all this shielding to happen. So now, at any point in time, this electron can be pulled in by this proton, and this proton, and this proton. Let me change colors. At the same time, at any point in time, this electron can be pulled on and inwards by this one, and that one. And then, finally, this final can be pulled in at any point in time by all 3 of those. So now it's kind of like having 3 tethers. And so you may not be able to completely tell, but the nucleus, not the nucleus, but the entire atom gets smaller and smaller as you go in this direction. And that's because the outer electrons, even though there's more protons, it's actually like the more protons are extra eyes on the kids, basically, and they keep calling them in and don't let them run really far.